Welcome to my hydrostatics crash course on pressure. First, a quick look at the meaning. Hydro means relating to water, static means no movement. The pressure at any point in a static fluid has a single value and is independent of direction. Civil engineers typically deal with water at 20 degrees C, where the density is 998 kilograms per cubic meter. For any static liquid, we have ρ for density, g for gravity times h. And when dealing with water, we have the density value known and we know g. But what is h? H is the depth under the water surface that is exposed to atmosphere. Consider these different points, and the pressure at A, B, C and D would simply be ρ times g times the related h values. We've got the density, we've got the gravity, and we've got the different h values if we know the dimensions of the tank. What happens if we split the tank in two, considering A, B, C, D on the left and E, F, G, H on the right hand side? Of course, we'll have similar depth values to the different points, and we have water on both sides of the tank. So simply the pressure would be equal at A and E, at B, F, C, G and D and H. Now, if we use different fluids, let's say water on the left and oil on the right, the values would change because oil has a different density, let's say 800 kilograms per cubic meters versus water on the left. The different pressures would simply be found by taking the densities times the H values for water on the left and oil on the right. We can complicate this further by having oil float on top of water in the same tank. Now, consider the interfaces between the different fluids, exposed to air at the top, of course. At B, we would have the density of oil giving us the pressure at B with the H down to B. And now at point D, what is the pressure there? The pressure at D would simply be equal to the pressure at point B plus the ρ GH of the water below. Okay, so since the pressure is a function of the depth, if we go to any other similar depth, of course the pressure would be equal. So looking at point H on the right, the pressure would be equal to point D on the left, because this is all the same fluid. Now consider another example with a pipe and 3 points A, B and C. How would we find the pressure at these points? If the left is exposed to atmosphere, so this pipe is open on the left, and the right hand side is also open to atmosphere, so both sides are open, we simply require the depths to these 3 points, HA, HB and HC. And once again, pressure equals ρ GH. Ρ is known because we know it's water, and we've got the 3 H values, HA, HB and HC.